This episode of the Troxel Podcast is made possible with support from ArchIT. Are you tired of standard IT services that miss the mark? Choose ArchIT for specialized, proactive IT management, BIM support, and robust data security tailored for architects. Whether you're a team of 10 or a growing firm of 50 plus, ArchIT understands the architecture industry and will empower your unique creative vision to enable you to do your best work. Embrace a technology team that enhances, not hinders, your design process. Visit getarchit.com for your free IT assessment and start transforming your firm and your tech experience today. That's getarchit.com. Welcome to the Troxel Podcast. I'm Evan Troxel. In this episode, I am joined once again by David Benjamin from Autodesk and Thomas Van Haren from Innovating in the final installment in this three-part series on Project Phoenix. Thomas Van Haren is Innovating's Chief Operating Officer, where he is responsible for the raw materials and Mycelium composite business lines across the United States and Europe. Innovating is scaling its Mycelium technology to provide an alternative for industrial farming and to replace plastics. You know, no big deal, right? He graduated from London School of Economics and holds an MBA from Columbia Business School. David Benjamin leads applied research on net zero buildings at Autodesk Research. His work combines research and practice with a focus on an expanded and actionable framework of environmental sustainability. Over the past several years, his team has explored generative design, low-carbon materials, and reusable design intelligence for the built environment. Today, we are discussing the journey of creating sustainable building materials using Mycelium, the history of Autodesk and Innovating's partnership and the evolution from demonstration projects to scalable solutions, insights on the importance of digital workflows, the challenges and innovations in building facades, and the incredible versatility of Mycelium as a materials platform. And we also talk about the potential of Mycelium to revolutionize various industries and the urgent need for scalable, carbon-negative solutions in architectural building materials and beyond. Before we get into today's conversation, once again, please do me a couple of favors if you haven't already. If you're enjoying these episodes, please subscribe to the show on YouTube and in your favorite podcast app to let me know that you're a fan. And if you're watching on YouTube, please click that like button too, just under the video. It really helps. And finally, if you'd like to get an email when episodes are published with all of the links and other information about the episode and the guests, sign up at trxl.co, where you can find every episode of the show, including parts 1 and 2 of this series. This was a fantastic conversation with Thomas and David, and I hope you'll not only find value in it for yourself, but that you'll help add value to the profession by spreading it. So now, without further ado, I bring you my conversation with Thomas Van Haren and David Benjamin for the final part 3 of the Project Phoenix series. Today, I'm joined by David Benjamin and Thomas Van Haren. And David works at Autodesk, Thomas works at Innovating, and these are both companies that have come together on Project Phoenix, which we've talked about in the past on previous episodes. Today, I'm especially excited because as an architect, we're going to be talking about building materials and unconventional building materials at that. I'm going to bury the lead for a few more minutes here until we hear about this interesting new development, at least new to me. And I'm going to let you start, David. And if you could tell us kind of about this partnership between Autodesk and Innovating, how long that's been going on. Is this the first project that you've collaborated together on? I have a burning sense that the answer is no. I mean, it takes a while to come to something this innovative. So kick us off with a story about how this partnership was started.
Great. Well, thanks, Evan. So for me, the story began about 10 years ago when I was working on a project with my team as part of an invited competition run by the Museum of Modern Art called the Young Architects Program. And this was a really interesting program that invited young architecture firms, kind of unproven architecture firms, to propose an innovative idea for a pavilion in the courtyard of MoMA PS1 for the summer. And at the time, we were very interested in sustainability, in materials, and particularly in biomaterials. And we came across the amazing things that Ecovative was doing with materials. And Ecovative was basically, and Thomas, you can describe more about this in a moment, but Ecovative was creating materials, functional, useful materials out of mycelium, which is the root-like structure of mushrooms, and agricultural waste, which is like the byproduct of growing corn or other crops. And Ecovative was taking this stuff and making materials for packaging and maybe some other applications. And we thought, being architects, that we would love to use this same material to make bricks, to make architectural load-bearing bricks to make a structure. And we got in contact with Ecovative and took the train from New York City up to their facility in upstate New York and kind of proposed our idea. And Ecovative, I think it was Evan and Gavin at the time, Thomas, and they kind of listened to our proposal and thought it was pretty interesting. We talked about, different strengths of the material, different ways that the Ecovative makes it. And at the end, they basically said, well, we're probably going to pass. They thought that that they didn't necessarily want to get involved in that project. And I learned later some of the reasons, some of the challenges for that, some of the difficulties of different markets and liability issues and things like that. But in the end, after more discussion, some back and forth, us kind of pleading our case a little more, and some testing that we did, we figured out that we actually could make a structure out of this material. And we created a 40-foot tall tower out of about 10,000 bricks. So I always think like more than just a few units, more than just one-story building, to test out whether this material, making load-bearing bricks out of mycelium material, could actually work. And it was generally, pretty successful, pretty well received. And just to kind of wrap up the story, we can talk about any details of that if it's relevant. But this was almost 10 years ago exactly, and because the project was at MoMA, it got a lot of attention from architects, but really more attention probably from the general public. And one of the questions that I was asked most frequently at that time was something like, yeah, this is interesting, but when is this going to be in a real building? And,
right.
It was like annoying to me. We had worked so hard just to get this like thing, and it was big, and,
Sure.
it took so much engineering. We had other partners, including the great structural engineers at Arup and, great people building with us in New York City, brick masons stacking this thing. We did all this hard work and people were kind of dismissing it, but at the same time, I knew that was exactly the right question to be asking.
Well, you obviously just made it look easy, right? Like this was one of those things where it's like, well, nobody sees the 10-year-long struggle to success. They only see the success part, right? And so
Yes.
Building materials are proven over time. And so there's probably this automatic assumption, right? Which is like, okay, where are we going next, right? We're always, where are we going next? So I love that it kind of perturbed you a little bit because you're like, you don't even know what it took to get here.
Right.
Right.
Let's talk about like how far we've come, but people just
Right.
wanted, but I knew that was, the right question. And I think at the time I said something like, because I had learned from Ecovative about this material and the possibilities. And I said, based on my experience in the past year, bringing this to life, I'm pretty confident that in about 10 years, we'll be able to have this in a real building, in a real permanent,
Nice.
Regular functional building. I did not necessarily think that I would be part of a team with you, Thomas, and others to bring that to life. But, and both Ecovative and me and my team, we did many different things over those 10 years, but we've come back together just recently to try to bring this to life in a real building.
That's fantastic. I had no idea that it went back that far. And so Thomas, now I'm really interested in where you enter the picture, right? Because now David kind of painted that story of how you got to maybe where we are and where we're going with Project Phoenix and what we saw at Autodesk University. But tell us your story and how you got involved at Ecovative.
Yeah, and just going back briefly to what David just said about, people asking, when is this an actual building? It's interesting because, you need some visionary people who see it, who see the application, who actually see the future in it. And, obviously we always refer to David as being one of them and, the early adapter when it comes to building materials. But at the same time, Ecovative has now been around for 16, almost 17 years. And we joke internally that we are the world's leading mycelium construction materials business, yet we have never used any mycelium materials in an actual building. So it kind of shows you how long it takes for something like that to be not just to gain interest, right? Because there's a lot of interest in mycelium, there's a lot of interest in kind of the technology, but bringing it to life in a real life project is a different story. That's really where we are today. And yes, that took 10 years or longer than that, because and I guess maybe that's a good segue to explaining kind of how Ecovative got there. So the business was founded by Eben Bayer and Gavin McIntyre back in 2008, right out of college, with a inventors class where they came up with a way to bind agricultural waste materials using mycelium as agriculture as kind of nature's glue, right? So it's a binding process where the mycelium self-assembles and binds together agricultural waste products. Initially, that was actually focused on two things: packaging and building materials. And we have made things. Variety of things in the building and construction material space, ranging from e-wood and bricks to insulation. And so we have spent kind of a long period of time since the inception of the business trying to commercialize that product as well as our packaging product. Along the way, you kind of start to find out how hard it is, specifically in industries like packaging, and like construction materials, how long the cycles are, right? So it takes a very long time to get first people to buy into the product, to test it themselves, to validate it as a useful and valid alternative material. And then you need to go through the entire cycle of, getting it approved and, having people actually utilize it and value it in a way that fits with how Ecovative values it, right? And so along the way, we came up with different technologies to use mycelium as well. Today, our largest products are actually not what we call the microcomposites technology, which we're talking about today, but we are focused largely on growing 100% mycelium tissue slabs in a traditional mushroom growing facility that we harvest and either treat into bacon, vegan bacon, under our brand name My Forest Foods, or into leather, customary foams. So those are slightly different than the technology we're talking about today. That is 100% mycelium. Microcomposites, mycelium is just one of the ingredients, right? And so, when David came to us to kind of take a look again at building materials, really we would have said no to everyone except for to David, because David is one of those people who has a long-standing history with us, and who has the vision to bring that to life. And so I think about a year ago, David, we started talking about how do we bring mycelium panels into the market as an alternative for EPS foam. And so that's what we've been working on since.
Thomas, I'm glad you're reminding me and everyone else of the amazing other things that can be created with mycelium, and that's a whole other, just such a mind-blowing thing that one living organism, can be used in one way for food, in another way for packaging, in another way for building materials, in another way for clothing like materials. But But I just wanted to emphasize that something that's been really important for me is I think my thinking changed over the past 10 years. I'm just as excited about mycelium materials as I was 10 years ago. But one part of the equation for me is the importance of going from demonstration project to scale up. And 10 years ago, I was more focused on demonstration project. And the world needs good demonstration projects in innovation, but especially in decarbonization and climate and architecture, we need to rapidly scale up. You know, we can't just have another 10 years of good demonstration projects without the scale up. We need the demonstration projects, but we equally need the scale up. So when we started talking together again, Thomas, a year ago or so, we were very much focused on the scale up, not only on getting this in a real building, but on what I have been calling like a drop-in solution. Something that can be used with today's building codes and certifications and construction processes. It can be dropped right in, kind of like biofuel can be dropped in to today's vehicles, and we can start using it today. So we were interested in a way, Phoenix is both. It's a demonstration project, but it's also a critical step on this scale up, because if we can make it in this real building and get through all of those, steps to prove that it can be done, then we hope it will unlock, a lot more scale up.
Yeah. To your point, David, I think a lot of people have probably watched the Fantastic Fungi documentary on Netflix, and the application of mycelium is incredible, right? Like across the range. And I mean, going back to Ecovative's beginnings, you said that this started out as a research project in school. Was that right? So like, how did where did this initial spark to pursue potentially building products? I assume at that time, maybe there was like a giant map on the wall of all the opportunities, and there was like focusing in, but was it the two founders who were just like inspired to say, how can we apply this to building products? I mean, that it's just incredible to think of how far this has come in what is really a relatively short amount of time.
Yeah, and Evan tells this story much better, obviously, because it's his experience, but he grew up on a farm and kind of took that knowledge with him to college. And when he did an inventors class with Bert Swersey, a professor at RPI, they came up with using mycelium as a natural glue. I think he's done that course once, and the second time around, Gavin joined him. And then that they spun after college, they spun that business or that project really into a business. But yeah, I think, to answer your question on, how does that go, right? I think it's as many startups, you start working on one thing and that leads you to the next thing. And that's really a very simplistic way of explaining how Ecovative evolved throughout the years as well, right? Before Ecovative, there was no mycelium industry. Mycelium as an alternative material did not exist before Evan and Gavin came up with this product back in 2007 or 2008. Really, mycelium was only used for, inoculating substrate for the commercial mushroom growing industry, not for using mycelium, and eventually the mycelium would pin into a mushroom, right? It was not used as an alternative material before they started working on this. Today, there are tons and tons of startups and businesses working on mycelium, with mycelium, whether that's with our patents and with our IP or not. There's a lot of interest in it, and partially triggered by documentaries like Fantastic Fungi, and there's a bunch of other ones out there as well. But to really drive that point home, the Ecovative evolving as a business from packaging and building materials to bacon and leather, that all, obviously went like this, but it's one invention that led to the next one, right? So if you look at our material, for example, the bricks that we use, there's a thin layer of what we call overgrowth on the microcomposites products. And that overgrowth is 100% mycelium. And that led us to the innovation to use 100% mycelium as an alternative material as well. So yeah, it's definitely a very, very interesting path. We have a lot of licensees around the world. Last year, September, we actually decided to open the microcomposites patent in Europe, UK, and Israel under the open patent program for that particular region. And we did that to, get the technology into more people's hands, to drive more innovation, and because there was so much interest, particularly coming from Europe, with people who wanted to get their hands on the material and the technology, and we decided that it would be best for that technology we share it with more people, so that we drive more innovation. And to David's point, get to a faster adaptation of using that material in real life, right? Because we're definitely not there yet, in particular with the composites technology. We're a long way from having all the EPS and styrofoam and packaging being replaced by mycelium-based packaging, and we're probably further away on construction materials. To be fair, so there's a lot of innovation, a lot of scaling up that needs to happen, and I tell actually everyone in Europe that I speak with about our open patent program, I tell all of them, don't focus on the substrate, don't focus on the strain, focus on scalability. You need to figure out a way to scale this to make it as cost competitive as your EPS or your incumbent materials. That is the only way in which you're going to build this into a real business and make an impact. But in the end, it will have to be adopted by people like David and people like Factory OS and the architects behind the project. And yeah, we're really excited to see the excitement on the Phoenix project. It's had a lot of exposure, and people are really genuinely excited about it. So yeah, it's great to be part of that.
This episode is made possible with support from AVAIL. AVAIL makes the best software to manage all of your AEC digital content. Dedicated to developing tools that save AEC teams time, AVAIL has now added Revit Application Version Management to its suite of content management capabilities. Once a painful manual process, Revit Application Versioning is now automatic for AVAIL customers. Publishers simply upload files to an AVAIL channel, and the files are automatically converted to newer versions from Revit 2021 through Revit 2025. For users, the experience is then seamless. They can search, select, and utilize the Revit content in AVAIL, regardless of what Revit version they are working in. Inquire about a demo of AVAIL and its new Revit Application Version Management features today at getavail.com/request-demo. My thanks to AVAIL for supporting this episode of the Troxel Podcast. And now, let's get back to the conversation. So obviously, Autodesk was looking for an innovation partner when it came to this kind of application of an innovative product on a building. But David, where does the digital thinking come into the actual physical product of the Mycelium panel system?
Yeah. I'm glad you're asking about that. I think if we think about how buildings get made, and Evan, you're an expert on this. There's a lot of players. There's a lot of aspirations for each project, constraints for each project. There's a lot of potential risk, and we realized that if we were going to scale up mycelium materials and other carbon negative materials, so I hope we can get back to that way I'm thinking about it now, we need those materials to be part of digital workflows. So you think about how we get how ideas get started and how things get modeled in the computer, how design for a project gets passed from an architect to an engineer, how the design advances through the stages, how things get communicated to contractors, how things get analyzed for sustainability impact. And all of that, it's really important for there to be data about, things, whether that's the geometry or the materials or other aspects, and, some way of analyzing and comparing things. And these days, that's basically software. It's many kinds of software. It's not only Autodesk software, but a lot of that is software. So another way of looking at the whole problem of decarbonizing architecture, even independent of mycelium materials, but I think I'm going to try to describe where these things intersect, is if we're going to decarbonize architecture, we need to reduce the operational carbon. There are a lot of good digital tools for that and designs and even traditional practices. We need to be able to model and simulate that, but also increasingly the embodied carbon of materials. And thankfully, a lot of architects, people in AEC are paying attention to that now. But as soon as you're thinking about embodied carbon in materials, you need precedents. You need to be able to simulate the structural performance of different material options. You need to know the exact carbon footprint of different materials, amount of embodied carbon. And so we thought, as we were trying to do some of this innovation, that it's not only the physical buildings of Phoenix that will help, be one step on potentially scaling up, but it's also getting that material innovation into digital workflows. And so we've been not only trying to simulate the material to figure out what its performance is for things like structure, noise dampening, thermal performance, and those are all really critical, and those help us unlock some cost benefits. So we need to do that simulation. Some of that's in the computer, some of that's physical testing, also fire testing. But then we need to have that information available for the next designer who's going to come along, or engineer or building owner who might want to use this. And including one of the latest things we've been doing is a full life cycle assessment of the material so that we can basically know in a high degree of detail with third-party verification how this material performs in terms of sustainability. So anyway, that was a long answer of how we think, if you're going to scale up innovative materials, you need, the physical implementation, but you also need the kind of digital thread that's going to help other people do it in the future.
Absolutely. You mentioned risk, and as an architect, I just got back from the National AIA conference on architecture, and there's a bunch of exhibitors there all showing off their building products. And I think as an architect, as architects normally do, they want to see they want to see the application of it before they use it, which is hard when you're talking about a new material, right? And so to speak to your scale point of view, right, and getting it out there, getting it used, having all the testing in line and at the ready for when people ask for it, I mean, all of that plays into the adoption of new building products. And we want, our reputation relies on these things performing like you say they're going to, right? And like you've modeled. And so this is a long process. I can't imagine how hard that actually is to embark on. I mean, to talk about risk, you've taken a ton of that risk, Thomas, evocative, right? Sorry, I said it wrong. With Ecovative, to actually put in the funding and the time and the science and the manufacturing and doing all of this to actually get it to the point at which somebody can actually say yes to using a new innovative product on a building. And even then, they're likely like the first ones in their area doing it, and that's risky for them. And so you have to be able to say, we're partners in this. And so I'm wondering what is the story that you're telling people publicly with a product being used on a project like Phoenix to say, like, there is trust in this, and there's a relationship, and there's collaboration, and we've got your back. And like, how does that all go? Because I can only imagine how hard it is to, like, to me, it's a new product category. And when you're talking about a new category, it's like, no thanks, I'll use what I've been using for the last 20 years on my projects. I mean, that's just kind of normal when it goes for architects. So how do you start to kind of get over the objections of introducing a new material category into the building and construction industry?
Well, let me first, and then David, please jump in. But it's not just hard; it's also very, very frustrating, right? Because like there's a lot of people who are interested in it, but actually taking that step to commercially adapt it is, completely different story than to David's point on, doing a pilot or doing something in a lab or doing something very, very small scale. But actually bringing it to a real sized project is a completely different ball game. I think for me, the reason why it has a higher degree, a higher likelihood of succeeding in the Phoenix project is because you have, all key stakeholders and all parties together, all pulling for the same thing, right? It's generally one stakeholder that wants to bring a product in. And then there's lots of other parties who then start looking at it and saying, this is the reason why we can't do it, or this is off, or the price, or, the testing, or whatever it may be. In this case, you have the architecture firm, you have the developer, you have the panel manufacturer, you have Ecovative, and you have David's team, all coming together with one shared goal, that's to actually bring this product into a real building. And I think that's the game changer here, is having all those people together. And that's completely to David's credit that, he brought that group together and said, let's take a look at if we can actually do this, right? Forget about a mock-up or a lab scale. Let's see if we can actually bring this to life. But David, jump in with what your view is on.
No, I mean, I love that description, and that was really true. And that was one of the most exciting things about the project, that we did have all of these stakeholders working together, with the same big picture goal in mind, and there was a lot of issues to solve and sometimes disagreements about how to get there, but it really was a collaborative group. And that is somewhat unusual, because we had not only the modular housing manufacturer, Factory OS, but then their development arm. So really the building owner as well, was there in the room. We're all in the room. One of my favorite moments in the project, Thomas, I think you may not have been at this meeting. I'm based in New York, but I was at several of the meetings in the Factory OS office in the Bay Area. And, there were some challenges of using this innovative material as you've already described, Thomas, like to do good innovative work, there are always going to be challenges. And Larry Pace, who's this incredible veteran of the construction industry, had a full career in traditional construction before deciding that construction had to be different and starting Factory OS with his co-founder, knows everything about how to make buildings, knows every product out there, knows how much anything is going to cost, gets in there and is drawing the detail with us, even though he's, the CEO. He recently passed that on. But so Larry's in the meeting, and someone had the courage, I think, not necessarily in a good way, but the courage to say something like, well, what if we just don't use the mycelium on this project? And Larry Pace took his big fist, slammed it on the table, and said, the whole point of this project and all of our work is to get this innovative material in this building in Phoenix.
Wow.
He basically insisted that we needed mycelium in Project Phoenix. And to me, that was a huge step in itself, to have someone who knows everything about construction, everything about the risks, who's going to be taking some of the risks himself, be so bought in to this material innovation and influencing the construction industry that he just insisted on it. And at a certain point, I'm sure every innovation story has something like this. You need someone like that to just say, this is the goal. We're going to make it happen. We're going to, and even if there are failures along the way, we're going to put this down as the target. And so that I'm always going to remember that moment. I was somewhat surprised because I knew that he's so practical. This is, by the way, affordable housing with a very short timeline. a strict budget, and he was saying, we're going to commit to this anyway.
Yeah. That is interesting coming from the construction side as well, right? Normally,
Yes.
as an architect, we have the crazy ideas, and I'm using my podcasting air quotes, that get shot down or value engineered out of the project. And for, project owner, but also builder, to really double down and say, this is the whole point. I think that's absolutely incredible. I bet that was an amazing day, and thing to witness, right? Because you are coming at this often from the design side as well. And for the story to be owned by the contractor like that is a fantastic story.
Yeah, absolutely.
I'm interested in, go ahead.
Well, I just wanted to describe one other thing that I think helped us all unlock a little bit of the potential here. And it's interesting to me, even to generalize from this toward other kind of innovation. But in this particular project, especially because, maybe some people listening, hopefully have heard about Mycelium, have seen it, know what it's like, these kind of Mycelium composite materials. And in this case, in taking this step for scaling up, we had to do another thing that we haven't quite talked about yet, which is combine Mycelium, a very carbon negative material, sustainable material, a biomaterial, with a small amount of a traditional material. And I think that step is worthwhile and important, and maybe will help us get to a point where we have 100% carbon negative and biomaterial, sustainable biomaterial. And so there are two ways to think about this in my mind. One is we have this mycelium material, which can do incredible things. It's structural, it dampens noise, it has thermal insulation. Most importantly for me, it's carbon negative, meaning there's more carbon absorbed during the process of making it than emitted. That's because it's using the agricultural waste, and all plants have absorbed carbon dioxide. So it's got all these great possibilities, characteristics and possibilities, but it has a couple of challenges in being in a real world building. And we picked one of the most difficult applications, which is the facade for performance. And a couple of challenges are the durability and the strength compared to other materials. So for the strength, Thomas and his team did some incredible innovation to get us where we needed to be. And for the durability, we chose, so I sometimes think of it this way, we chose to take the mycelium material, which can be kind of a block or a panel that we're going to use in a facade, and coat it with a very small amount of a synthetic material to get the durability. So, you have this material, it's like by volume, it must be like 95% or more mycelium composite material. And then a very thin coating, almost like painting something on. And that is FRP, fiber reinforced polymer or fiberglass. So that's one way of thinking about it. Another way of thinking about it is FRP is a high performance building facade material that's kind of taking off. It's spreading through the industry. It's got all these really interesting properties, incredibly durable, very lightweight. You can make huge panels out of it. They can be constructed very quickly and save you time and money. And typically it would have a core material. So you have a layer of fiberglass, a layer of often foam, synthetic foam, polyisofoam or EPS foam, and then another layer of fiberglass. And so another way of looking at this innovation is we're going to substitute the core material. We're going to take out the polyiso or EPS, and we're going to put in this biomaterial, mycelium composite material. And we're going to have something that has all of the advantages, existing advantages of FRP facades, but one additional advantage, which is the carbon footprint, the sustainability.
Right.
And so that's been really important. I think the vision is we can get to a facade one day, maybe in another 10 years, but don't quote me on it, where it's going to be 100% organic biocomposite facade. But for now, this step is really important because we can get the best of both worlds. And crucially, we can still get a carbon negative facade. So overall, it's got a negative carbon footprint. And then we have all of the advantages of FRP, which, and it made me think of it again, because that has helped us pass a lot of the tests, because we have this composite. And I think it's a totally valid step along the way to the most radical sustainable future we can have. We need these steps like this, which are a step along the way. It's not all the way there yet, but it's an important step.
When you're talking about go for it, Thomas.
Oh, I was just going to add, I think, the Chrysler panels, obviously alleviated a lot of concerns as well, right? I mean, it's what we were talking about before. How does it perform long term? Where is this what does it actually look like in real life? Having the mycelium material being completely enclosed, right, wrapped in a proven material, kind of took all of those concerns away. And you would say, okay, from a performance in terms of being exposed to the elements or other risks that you're taking, it kind of pushed that risk down a lot because FRP is a proven material. And by doing it like this, almost in a step-by-step basis, it made it a lot more palatable, I think, for people on that whole project team and for us as well. So, yeah.
Absolutely. I think that this is kind of the natural progression to get from one end of the pendulum to the other, right? You've got to have step change along the way. And so the gradient of, what makes sense for people to adopt it because you have proven technologies, marrying that in a composite sense with an unproven technology to get over those objections, I think makes a ton of sense. And also coming from a durability standpoint, as an architect of public projects over the years, like this is the very first thing that anybody who builds a school or, you've got affordable housing projects, like there's going to be the owner who's going to be like, they don't have a huge windfall of a budget for building maintenance, right? I mean, we've all experienced this. It's like buildings don't go through the car wash like your car does, and so they don't maintain themselves, right? And so when you're thinking about the durability and maintenance staff and having to even from an industrialized construction standpoint of having to ship these things, and things get banged up in shipping, right? Like that's normal too. And so thinking about it from the standpoint of this logistically has to work. You have to get it from the manufacturing facility to the site, and transportation is not like a touchless process, right? So thinking about all of those things, I mean, this totally makes sense. And Thomas, I'm just wondering if you can kind of paint a picture of what this product actually looks and feels like, because that's something we haven't really talked about. I know you had a lot of great samples on display at Autodesk University that people could pick up and touch, and there was different kind of texture levels and things like that to this product. But if you could maybe describe what we're talking about here to give the audience an idea of what it looks and feels like, that would be fantastic.
Yeah, so I think the composites product, when it's finally said and done, obviously, we grow these things in molds. You can do it in very large molds or in small molds. It's a hemp hurd, so it's basically a waste material from the fibers industry that we then mix with the mycelium, and then it self-assembles, and eventually we'll grow it a little bit more. It takes about 5 days for that material to bind and grow. We take it out of the mold and let it grow for another day. Then we dehydrate it in a large scale oven or a dehydrator or kiln. And the final product then feels a little bit like, think of it as a slightly heavier, more natural feeling styrofoam or EPS, right? It feels like it's almost like an e-wood type of material that if you overgrow it properly, right? If you have a little bit of a layer of mycelium around it, should feel soft and velvety, but you can also grow it very hard, where if you rub your hand over it, it feels more like kind of unbrushed wood, almost like a rough wood type surface.
Right.
So that's really what it looks like. And then obviously with the Dave, you could probably speak to this better, but with the FRP panel around it, it feels like a regular FRP panel. You just don't know what's inside, right? Inside is the mycelium material as opposed to a polyiso or an EPS. So yeah, that's kind of the final product.
This episode is made possible with support from AVAIL. Along with their newly released Revit Application Version Management, AEC software company AVAIL has added another powerful new workflow feature called Palettes to its suite of content management capabilities. Palettes are user-customized lists of content in AVAIL and can function as a favorites list, as starter content for a specific project, or to drive workflows such as redlining construction details. Customers administrators can add palettes to their accounts through the AVAIL Manage portal page today. Interested in seeing palettes in action first? Request a demo at getavail.com/request-demo. AVAIL helps AECO firms better manage, organize, and navigate information faster. My thanks to AVAIL for supporting this episode of the Troxel Podcast. And now let's return to the conversation. And speaking about kind of performance characteristics, can you list out kind of what you're seeing, and maybe even go back to maybe what you thought the possibilities were, and then what has transpired throughout the creation of these panels?
David, you want to take that?
Yeah, I can get started with the overview, but I think Thomas, you obviously have more of the fine grain of detail. But we talked before about all the players in the room trying to work together, and there were a lot of really interesting moments where we were listening to each other, brainstorming together, and something that really was helpful and unlocked some possibilities for me was hearing Andrew from Factory OS, who I know, Evan, we've talked to before, talking about how the facade in the modular housing assembly process is one of those, challenging things. You can make the boxes in the factory, but you got to put the facade on in the field for the most part, unless you innovate. Because you got to stitch the boxes together and the waterproofing. Right. It's easier to do that on the whole building, not on each module, et cetera. So he was just talking about the inefficiency of that process and the 5 things that he has to do in the field to make these facades work. And he ticked them off, and they've become part of my thinking ever since. Let's hope I can remember them. I mean, the first one is structural. You got to connect the boxes together, especially laterally. Then you need waterproofing, you need fire resistance, you need noise dampening, and you need thermal insulation. And often these are separate trades going on, and it takes a long time. It's back to traditional construction, and it costs a lot of money because it's taking more time. And we started to realize maybe our hybrid facade with the Mycelium and the FRP could provide 2 of these or even 3 of these. And now we're aiming for 5 of these layers of performance. Nice. So that's been my list. It starts with what do they need to do in the field to get this building completed? Those 5 layers that aren't already part of those boxes. But this is generalizable to non-modular construction as well. And we've been seeing that, kind of remarkably, mycelium material helps with the fire rating. And we've done those fire tests, and we've, done them to specifications. We've passed the Class A fire rating for buildings in California under 30 stories as the assembly of mycelium and fiberglass. We're doing even further tests right now for the noise dampening, which already the material came with Thomas and Ecovative had these tests saying, yes, it's going to be good for noise dampening. We have some data about thermal performance, and the other and the structure we've been working on together. The waterproofing will come just through the detailing of the assembly. But so we're able to get those 5 layers of performance, or we're optimistic. Some we've proven already, some are in process. And that will unlock not only a good facade, a high performance facade, but really essentially cost. Because if we can take a single 38-foot long panel and assemble it pretty quickly in the field without scaffolding then we can save, as many as 5+ months of construction time. And that will unlock, obviously cost savings that might make it worth it to spend a little more per square foot on this material, just of the material itself. But, and Thomas, you've been instrumental. When we came to you and we said, we were already working on this, and we said, okay, let's work on the fire. You were like, here, we've done all these tests. We have all this data. Here's the stuff. And when we said, now let's talk about noise, you said, yes, here's the, but for structure, and you also said, we've done all this stuff, but we did some more together, just for this project. So we've really been working to make it work for this project, which we think will be generalizable to a lot of other projects.
Yeah, and I think that's been the most surprising thing to us, at least, about the project, right? It's when you came to us, it is really only a replacement of the existing filler material, right? Doesn't necessarily have to perform as well. And I think we knew that the material would pass fire rating. We also knew that it had some thermal insulation value and some acoustic and good acoustic properties. What we didn't know, what we've been surprised about, and that's definitely, credit to how much work we all have done on testing it and implementing it in the right way, is how that whole package performs together. Not just from a performance, but also from a structural perspective, right? We were very concerned about, is this actually going to hold up? Can you actually use the mycelium and bind it in a way inside an FRP panel that will then also allow you to appropriately put it on the outside of a building? I think what all of these tests are showing is that there's a path to getting that done, and not just benefiting from, oh, look, there's a funky, carbon negative material inside, but actually that material performs as well, and actually has an attribute to, the speed of the construction and to what other materials you can strip out as a result of that performance, right? And I think that's been the biggest learning for us, and I think shows very promising.
It's very interesting to hear how you're kind of ticking all those boxes, and I can see why it would be so attractive, obviously, especially in terms of speed, but also to your point about cost, David, right? When you are replacing 4 or 5 other things with a single thing, that makes a huge difference. And you mentioned weatherproofing, so it doesn't sound like this is acting as a rain screen, like you have to have a vapor barrier behind it, and you said you were going to accomplish that through detailing. Maybe you could just talk a little bit more about at least the direction you're going there, because I think that's another thing that architects who are listening to this might be interested in hearing about.
Yeah, so that's very much in process right now, in the final stage. The version that you saw, Evan, that we were presenting at Autodesk University was detailed as a rain screen. So we went in and we said, look how amazing this could be with, if this was an integrated system, not a rain screen. Mm-hmm. And everyone said, yes. But, and I remember, I don't know who came up with this, but, well, I know it's a common expression, but someone said, let's walk before we run. The very first version, let's prove that we can make a 38-foot long panel, get the detailing right, get the tolerances right, get all the, numbers for the testing, fire, acoustic, et cetera, and then if that works, then we'll do an integrated system. I believe this was kind of coming from the Factory OS side, and it made total sense. Look, I mean, that's the way to get things done, right? And everyone had their eyes on the prize. But after we did that full-scale mock-up, Factory OS said, you know what? Let's go for the integrated system. Let's see what it would take to do that. And that's what we're currently working on now. The biggest challenge is, the panels themselves, entirely waterproof. It's the same type of fiberglass, more or less.
It's just the edges, right?
Yeah, it's just where two come together, right? But it's the same material that's used for boats. So obviously it's in itself is waterproof. Now, I'm sure our great partner, Bill Chrysler and Chrysler Associates, they've got their own proprietary form of FRP, and it's highly engineered. It's incredible. They've got a whole, a career in super high performance, incredible FRP. So it is, even more than a traditional fiberglass. But within that unit itself, we're totally good. It all comes down to the detailing between two units. Well, and then we also learned, to my surprise, from Factory House's point of view, it wasn't that hard to get the connection and the detailing between the box and the panel. It's all about panel to panel detailing.
Yeah, right.
So, but everyone's pretty confident that can work.
I want to ask about size and shape because, again, to just kind of complete the picture for people who are listening. I've seen it in person, but I'm interested in. I assume you can do anything within a certain range, right?
Yes.
Shape, like how the flutes and the because it's a mold, you can kind of go crazy.
Yeah, I think that's right. And so, Thomas will describe this, but for the, both materials, the synthetic material and the natural material are created with molds. And so they can be any size and shape, but there's some details of that, which I don't know if they get too technical, but about how you can have a single 38-foot long FRP. In theory, you can have a single 38-foot long Mycelium composite, but we decided to do it in a more modular way this time.
Oh yeah, that makes sense. Nice. Thomas, can you talk about size and shape a little bit? Because, David's mentioned 38 feet. And if you could describe shape and kind of what the possibilities are with aesthetics, because you're doing this in a mold, I assume that there's a lot of possibility, but maybe just describe how it looks and feels a little bit more.
Yeah, there are a lot of possibilities. That's correct. You can really make any shape or form with the Mycelium. Now, the trick is in how do you scale that, right? So how we have initially scaled the business for our packaging product is that it is a mold that goes into a baker's rack, and you will grow those, and eventually you'll roll them into an oven. The downside there is that you'll need to have one flat surface, right? Because you're growing it in a surface or in a mold, and then you take them out, which will always have as a result that one surface is flat. Now that doesn't necessarily have to be a limiting factor here. We have made fully round things and completely other things by having two panels grow together, right? So after the initial stage, you can then bind them together by letting the Mycelium bind the two shapes together. So there's lots of different things you can do. The limiting factor obviously is how do you scale that, right? So how do you actually make sure that you have a surface or a form or a shape that you can actually replicate fast and at a low cost from a low cost perspective. What I would be really interested to see in the future, like David mentioned, that if we can grow this material directly into a panel, right, a massive 30-foot panel where we let the Mycelium grow and self-assemble, and then finish the panel off. That would be an ideal situation from a cost perspective. But yeah, in theory, there are no limitations, right? Our technology is being used for things from building materials, relatively simple shapes, right, to pretty intricate packaging products, all the way to human coffins, right? As you can imagine that there's lots of different shapes and forms that they've experimented with, and that's actually been pretty successful. So yeah, there's not a lot of limitations there, other than how you set up your production facility and how you scale it. And I think that's the nut that needs to be cracked in order to scale this up.
And just to make one other quick connection, that's another area where the digital workflow can be very important, because like you're saying, Thomas, you can basically make any size, any shape, and then eventually any size. And, you can translate really directly between 3D geometry in the computer and the shape of a mold. And you can do that both with the Mycelium product and the FRP product. So the same digital model, standard offsets and things like that. So it does, but I think, Evan, part of your point might be this is not only a 38-foot long panel that's carbon negative and durable and can be used today, but, well, and it could be 30 foot or 40 foot, whatever. But it's got a lot of aesthetic possibilities. So it's not like it's one color and one flatness and one aesthetic. You can make almost anything with it. And I think that's exciting too, to say if it's going to scale up, it can't just be like one finish. It's got to have expressive possibilities.
And you're getting a twofer there too, I assume, from trying to recall what I saw and just kind of putting two and two together. I don't think I heard this explicitly. This has to do with the sound attenuation that you're going for, right? Like you're trying to. The Project Phoenix is near a highway or a freeway, and so noise attenuation is a huge issue on this project. And so what we see in these outward-facing panels is getting you something else as well, right? And this is all part of that digital workflow, because you need to be able to model this and test it ahead of time so that you can do some modeling to see how it's going to react in that actual environment before you do it. And so I assume that the fluting that we see on these panels has to do with that as well.
Yes, exactly. Right. And so in short, if people are imagining, it's like we can make the facade thicker where it needs more noise attenuation, and also in some ways more privacy, because it can cause a thicker facade with less views inside an apartment, and thinner where it doesn't need that. And also the geometry itself, a little bit like you imagine if you're like in a recording studio, you have
like
a flat wall panels, is the worst. Yeah. But if you have more, shape, then you can help kind of confuse the noise. Diffuse it. Yeah.
Right. Yeah. So cool. What are we missing here in this story? It's fascinating, but I don't want to miss anything, right? So is there anything that we haven't covered in this? I mean, this project is yet to be built, and you've put some verbal disclaimers out there, like talking about future and the future of where this is headed, and obviously this is a direction, and there's a ladder to get there. Like we're on some step on that ladder to get where this potentially could go. But is there anything else part of Project Phoenix story or the Ecovative story and the Autodesk story of the collaboration between you two that we haven't touched on that you think still needs to be brought up?
There's one thing. Well, there's one thing that has always stuck with me, and Thomas, I'm curious for your thoughts on this at this point. So again, back 10 years ago, when I was so excited about the future of mycelium materials, and also trying to convince others, starting with convincing the original jury for the competition that, our project was important and relevant for the industry and things like that. One thing I cited, and I hope this is accurate, was that 3M, the big materials company, the inventor of Scotch tape and Post-its, and in essence, we could say like the ultimate pinnacle of chemical-based materials. I mean, and I did a project with them. I visited their facilities, and these guys are incredible at engineering with chemicals. And at the time, 10 years ago, 3M had just invested in Ecovative. And I believe I heard this, or someone told it to me, and so I hope it's accurate. My memory is accurate. But 3M said, why are they, the ultimate chemicals company, investing in biomaterials? And even back then, some people were saying bio is the future. The 21st century is going to be the century of biology. Even Steve Jobs is known for saying something like, we're going to have more innovation in the bio age than we've ever had in the computer age, things like that. So that wave was starting. But 3M, I think, said a little more practically, we think that mycelium has the potential to be a materials platform like plastics is a materials platform. And my interpretation of that is like, think of everything we can make with plastics. We can make clothing. We can make rigid materials. We can make flexible materials. We can make foam-like materials. Some can be transparent. Some can be opaque. You can basically do anything. Like it's a platform, right? Like almost anything you want. You can make a bag, it could be disposable, it can be permanent. Of course, we know there are a lot of problems with plastic, and even back then it was known. But the critical thing to me was platform. And my interpretation again was, there are many species of mycelium. You're already proving it, Thomas, even more than 10 years ago, that you can make food out of this. You can make fabric-like, leather-like things out of it.
Mm-hmm.
You can make brick-like things out of it. And more, you can make wood-like things out of it. And I think that's really exciting. And again, returning to the thing that's always on my mind, decarbonization and climate change, that is a powerful thing. If you're trying to decarbonize buildings and you have a new materials platform that is biodegradable and organic and with a negative carbon footprint, that is worth a lot of attention.
Yeah, I couldn't have said it better, David. And I think that's exactly how we look at Innovative as a platform company that will eventually have a number of verticals trying to replace plastics or other materials, right? And just tapping into what you said about plastics, the difficult thing is competing actually with plastics, right? Because it's such a great material. I mean, it's a crap material, but it's a great material, right? It's odorless, it's smooth, you can have any color, any surface, any shape. And that's an incredibly hard thing to reposition, society's perspective. And I think the even trickier thing about it is matching up society's perspective and government pressure on replacing plastics or other materials that are petroleum-based, and how quickly can get companies there, and how do they get their bottom line there, right? Like that is the tricky thing. And we are now seeing that, obviously for 17 years. And the composites technology that we were talking about has been around for 17 years. And the tricky thing is that, you need to match up momentum with where the adapters actually are. And I think getting those two things to align is incredibly difficult, right? Whether from a food perspective or materials or a building and construction materials perspective, getting excitement in the wider public's eye to align with, are there companies who are willing to take the bet, pay a little bit more, and thereby, drive innovation and adaptation of new product. Getting those three things to align at the same moment is incredibly difficult. But we're very confident in our ability to get there. And we think we agree with your view, David, that Mycelium has a lot of new products to bring to the table, and I think we're only scratching the surface. Commercial mushroom growing has not been around for that long, right? It's only been 150 years or so, compared to tens of thousands of years on domesticating animals and growing crops. So, we think that's how we eventually look at Mycelium as a new crop for the future that will bring different materials to society and to the economy. So we're definitely excited about that.
Mycelium has just been quietly waiting to be noticed, right? for so long. And the application potential is incredible. The sweet spots that you've identified right here on this project as kind of a case study to prove it to architects and builders who are looking for innovative ways to address the very real challenges that we're all dealing with from so many different angles, and kind of ticking all of those boxes that you both have outlaid here on this episode today, shows that they do exist, right? And this is something worth really investigating. And I'm hoping that there will be opportunities for people in these industries to really see it in action, go to the project and talk about it and touch it and feel it and really see how it's performing, because I know we need a lot of convincing as well. Like I said earlier, our reputations are on the line, but even more so than that, like it actually has to perform. It has to be one of those things that really lives up to everything that we're hoping it can do. So This has been a great episode, a great conversation. Thank you both so much for taking the time to share about it today. And I look forward to that time in the future where we can tour the project and see it for real. That would be absolutely fantastic. It was great to see the displays and kind of where you were at back in November at Autodesk University. But in construction terms, this is moving relatively quickly, and I can't wait to see it in action.
Great. Thank you so much, Evan. Great to talk to you, Thomas.
Yeah, likewise,
Thank you.
David, and thanks for having us, Evan.
Thanks to our sponsors, and thanks to our members this week. Find out how you can become a member at trxl.co, and I'll talk to you again next week.